Energy powers our modern world. From the lights in our homes to the factories that produce our goods, energy is essential. Today, we delve into nuclear energy, a powerful and often misunderstood source of electricity. We'll explore what nuclear energy is, how it compares to green energy and natural gas, and glimpse into the future with advanced reactors like thorium reactors. Nuclear energy is produced through a process called nuclear fission. This involves splitting the nuclei of heavy atoms, such as uranium-235, releasing a significant amount of energy in the form of heat. This heat is used to produce steam, which drives turbines to generate electricity. Unlike traditional combustion methods, nuclear fission does not produce greenhouse gases during operation, making it a cleaner option for large-scale energy production. Nuclear power plants are remarkably efficient. One uranium fuel pellet, roughly the size of a fingertip, contains as much energy as a ton of coal, 120 gallons of oil, or 17,000 cubic feet of natural gas. This incredible energy density means that nuclear power can generate a large amount of electricity from a very small amount of fuel. Additionally, the long operational life of nuclear plants, often extending over 40 years, provides a stable and reliable energy source. This stability is critical for meeting the continuous and growing energy demands of modern society. Many tout green energy sources like wind and solar power as essential for a sustainable future. However, these sources have significant limitations. They are intermittent, depending on weather conditions and time of day. When the wind isn't blowing or the sun isn't shining, these energy sources can't produce electricity, necessitating backup power solutions or energy storage systems, which can be expensive and resource-intensive. Additionally, the devices used for generating green energy, such as wind turbines and solar panels, create substantial waste. Once these devices reach the end of their life cycle, they often end up in landfills, contributing to environmental pollution. The sheer volume of waste compared to the relatively small amount of energy produced highlights a critical flaw in these technologies. Natural gas, while cleaner than coal, still emits carbon dioxide and methane, contributing to climate change. It also involves extraction processes that can be harmful to the environment. Hydraulic fracturing, or fracking, for example, has been associated with groundwater contamination and seismic activity. Furthermore, the infrastructure required to transport and store natural gas can be vulnerable to leaks and explosions, posing additional environmental and safety risks. The methane emissions from natural gas, a potent greenhouse gas, can significantly impact global warming if not properly managed. Nuclear energy, on the other hand, provides a stable and continuous supply of electricity, regardless of weather or time. It has one of the lowest carbon footprints of any energy source. While nuclear plants require significant initial investment, their operating costs are relatively low, and they can run for decades with proper maintenance. This makes nuclear power a cost-effective option in the long term, capable of providing large-scale, reliable electricity with minimal environmental impact. The consistent output of nuclear power is particularly valuable for balancing the grid and ensuring that there is always enough electricity to meet demand. One major advantage of nuclear energy over green energy is its energy density. Nuclear power plants require much less land compared to wind or solar farms to produce the same amount of electricity. This makes nuclear energy a highly efficient use of space, especially in regions where land is scarce or expensive. Moreover, nuclear plants can be located closer to urban centers, reducing the need for extensive transmission infrastructure and minimizing energy losses during transportation. This proximity to demand centers enhances the resilience and efficiency of the power supply. Safety is often a concern when it comes to nuclear power. High-profile accidents like Chernobyl and Fukushima have left a lasting impression. However, modern nuclear reactors are designed with numerous safety features to prevent such incidents. Advances in technology have made these plants much safer and more reliable. For instance, passive safety systems can shut down a reactor automatically in the event of an emergency, without the need for human intervention or external power sources. Additionally, ongoing research is focused on developing even safer reactor designs and improving emergency preparedness. Now, let's look at the future of nuclear energy. One of the most promising developments is the thorium reactor. Thorium is a more abundant element than uranium and can be used as a fuel in nuclear reactors. Thorium reactors produce less long-lived radioactive waste compared to traditional reactors and have a lower risk of meltdown. Additionally, thorium is more resistant to nuclear proliferation, as it is difficult to use in the production of nuclear weapons. The use of thorium as a fuel could address some of the key concerns associated with traditional nuclear power. Thorium reactors could revolutionize the energy industry. They offer the potential for safer, more efficient, and more cost-effective nuclear power. With thorium, we could see a significant reduction in nuclear waste and a more sustainable approach to nuclear energy. Furthermore, thorium reactors can be designed to consume existing nuclear waste as fuel, addressing one of the major challenges of nuclear power. This waste-to-energy approach not only mitigates the storage issues of nuclear waste, but also transforms it into a valuable resource. Imagine a future where thorium reactors provide a majority of our energy needs. This would lead to lower energy costs, reduced greenhouse gas emissions, and a more stable energy supply. The efficiency of thorium reactors means we could generate large amounts of power with minimal environmental impact. In addition, the scalability of thorium technology could make it accessible to developing countries, helping to bridge the energy gap and promote economic growth. Developing countries often face significant challenges in building and maintaining energy infrastructure, and thorium reactors could offer a viable solution. In conclusion, nuclear energy presents a powerful solution to our energy needs. It offers a reliable, low-carbon, and space-efficient alternative to both traditional fossil fuels and intermittent renewable sources. With advancements like thorium reactors on the horizon, the future of nuclear energy looks brighter than ever. By embracing nuclear power, we can build a more sustainable and energy-secure future. The integration of nuclear energy with other renewable sources could create a diversified and resilient energy system. It's time to rethink our energy strategies and consider the immense potential that nuclear energy holds. Thank you for joining us on this journey into the world of nuclear power. Let's continue to explore and innovate, ensuring a cleaner, more efficient, and more reliable energy future for generations to come. With ongoing advancements and increased public awareness, nuclear energy can play a pivotal role in addressing global energy challenges and achieving our climate goals.